What's up, everybody? So I know we were kind of flying through material today. We were doing a big review on chapter or unit 1 and module 12. We did a review on surface area today. So I sent you guys into the ether, otherwise known as the module here, module 13. I'm not going to really spend a whole lot of time on this because I think it is pretty self-explanatory and it's pretty achievable for you, but I figured I'd go ahead and do a quick video here to help you guys out. So here's module 1. The first part of the module, first the desmos of this thing. So if we're looking at these shapes, it says here are pictures that represents polyhedra. Poly meaning multiple, and hedra meaning like a shape. So it's a multiple-sided figure. Why they call these polyhedras, though, is they're multiple-sided figures that are closed. So if you notice, every single one of these objects, there's no openings, no gaps, and then they're all flat sides on the outside. Okay, there's really no rhyme or reason, with the exception of the cube. But these are all polyhedra. Some of these have more specific names, like this guy is a cube, and then some of these are like crazy names, but I'm not sure exactly what they are. But all we need to know is polyhedra, multi-sided closed flat figure. Okay, these are non-examples. These are ones that are not polyhedra. So a sphere cannot be a polyhedra. There's no flat sides. I know it's flat on the outside, it's smooth, but it's bent, it's curved. This automatically is out. This is a cylinder. The cylinder is a rectangle that encloses two circles on top. Circle on top, circle on bottom. There's a big rectangle on the outside. That you'll get to play with next year. This guy has opening and gaps. Can't be a polyhedra. And then this one's like a shoebox, but if you notice, it's open. It's not enclosed, so it's not a polyhedra. It's a rectangular prism, but it's not a polyhedra. They have to be closed, have to have those flat shapes, and they have to have flat sides and enclosed. Okay, so we moved along. What are polyhedra? What do you notice and wonder? So you're going to type that response in. I think a polyhedra is this. I tried giving you my best like adult version answer. You guys put in what you think they are as a kid. So they're enclosed, they're flat-sided figures. So I'm trying to hook you up there and give you some guidance there. I move to the next one. Select all the images that show polyhedra. Do not select images that are not. So again, I'm not going to do this section for you, but give you an example of like number 1. That is a polyhedra. It's flat-sided. It's enclosed. Right? Flat sides, it's got shapes, it's enclosed, no curves. Number 2, obviously, would not be. Then you would move on to each and every one of these other shapes. Are they enclosed? Is it all flat sides on the outside? Would that make a polyhedron? So we're kind of identifying shapes at this time. That's why I had you guys do this today on your own. Here's a warm-up synthesis. Okay, please make sure you understand these 3 terms because we're going to use these. But we have edges of shapes. That's like the edge where the 2 sides meet. There's a face. That's pretty much like a side. And then you have a vertex. The vertex is now going to be known as a corner. Okay, so again, it doesn't matter. Here's a triangular prism. Or a pyramid, I'm sorry, triangular pyramid. We have a flat face. That's like the side. Vertex, that's the corner. That's where it makes an angle. And you have that edge that runs along the face. This is basically just some definitions. We got to really know all the basics before we start jumping into the next forms because they get a little more complex. And again, you would follow these directions. Which images, numbers did you not select as examples of polyhedra? Why were those not? And you would move along. Okay? So going to the next section here, next Desmos. And then we're going to enter our code. I'm just going to use my third block because I just finished up with those guys and girls. QD7M. I would join that. Move along into our next piece here. So Mr. F. And we have a new module. Okay, you notice these are different terms now. It says here's some polyhedra. So we learned about enclosed figures with flat sides. These are enclosed. They all have flat sides, but now there's some new terminology. Prisms and pyramids. A prism is a polyhedra with flat sides that has a form of a base. So in this case, it has a matching pair of bases. So this guy is exactly the same as this. Every prism does. This guy, this one's kind of cheesy because it's a cube, but it still has the matching sides. Okay, this one also has matching sides. The triangles, that's kind of a horrible drawing, but you guys get the gist. There's a triangle. This one has a pentagonal side. So pentagon, this base here is exactly congruent to this base here, and so on. That's a hexagon. So that's basically where we're kind of moving along, is we have these objects. But why aren't these specifically called polyhedrons? Why are they called prisms? Well, a prism is an object that has those same bases, but it's connected by rectangles. So those 2 triangles, if you notice, are connected by rectangles. They're all the same height. rectangles. They're kind of like flat. This one's kind of it's a bad example because it's a cube, but it's still combined. This square on top, that square on top is connected by a rectangle. Here's my triangle 1. Here's my other congruent triangle. Here's my rectangle that connects this. There's 3 rectangles in this case. This guy, here's your pentagon on top. Here's my rectangles that connect me. So if you notice, guys, if you were to lay any of these shapes flat on a table, they would literally be parallel to the table itself. We call those the shape, the identifying shape. This guy right here, this shape right there is called a pentagonal prism because it's got a pentagon base and it's connected by rectangles. So we give it the definition name of a pentagonal prism. This guy has a triangle, right? So try to erase this so you can see the drawing a little bit. Base is triangle, base is triangle. You lay that flat on the table. This triangle here, that base, runs flat to that base. So this face of this triangle and this face of the triangle are exactly, they would be like perfectly level. They're connected by rectangles. So that's what a prism is. So look at the prisms. What are their characteristics or their features? What makes a prism a prism? That's what we just spoke about. So if you're confused on that, please rewind the video. Prisms always, it has 2 congruent bases. Triangle, triangle in this case, pentagon, pentagon, hexagon, hexagon. They're always connected by rectangles. So you got a triangular prism, a cube, triangular prism, pentagonal prism, rectangular prism, and a hexagonal prism. They all have rectangles. Now we have some pyramids. So these are pyramids. And if you notice, obviously you've probably seen a pyramid before. They're all triangular faces. Okay, they all come to a point. So all of these come to a point. So triangle, 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 point. Triangle, triangle, triangle. So you guys get it. Okay, the bases can be different. It can be a triangular pyramid. It can be a square-based pyramid. It can be a pentagonal pyramid. It can be a hexagonal pyramid. There's all kinds of crazy pyramids. And humans have built those all over the earth, which is kind of cool. There's some massive ones. So it's a lot of construction. There's some really cool, if you dig math, you should watch some videos on how they built the ones in Giza. They're massive. Some of the blocks weigh like more than like 3 melted cars. And it's crazy. There's millions of those blocks put together. They're like perfectly measured out. It's awesome. Really, really cool. But pyramids, triangular shapes, it could have any kind of base you like, but it's always got those triangles and they always come to a point. Okay? Prisms and pyramids, nets. Here's a new term. Well, we talked about this a little bit when we were doing the surface area of rectangular prisms, but a net is a 2-dimensional figure, 2D meaning flat, version of a 3D object. So it says, which of the following nets can be folded into pyramid P? So if you had pyramid P, that was on the back. Here's P, right? Pyramid P is right there. It's a triangular prism. Which of these nets would form that? That's our job. We're actually trying to take these 2D shapes, pretend it's like some origami, you're about to fold those up. Would net 1, net 2, and net 3 make P? We're trying to figure out which one of those would fit. And when they refer to pyramid P, they're talking about the previous problem. This guy right here, pyramid P. Whoops, and that's not going to work. So pyramid P is right here. That guy right there. Okay? So your job is to try to figure those out. Again, we're going to talk about this when we get to class, but I want to see how you guys would have done on that. This one says, select the polygon. These are polygons, right? Shapes needed to compose this polyhedron. And write down how many of each. So think about it. How many sides? Pretend that's like a camping tent or like a bike ramp or something. So what is this object, this polyhedron, this polygon, or this polyhedron, right? It's a polyhedron because it's an enclosed figure, flat sides. But what polygons make up that polyhedron? So what shapes would make it up and how many? That's what you're posting down here. So really think through that one. That should be pretty easy for this group. All right. And then we move on to the next one. Same type of question. We got a polyhedron. What kind of polygons would we need to make this and how many? What makes up that actual? And that's a pentagonal prism, right? It's connected by rectangles. It's got the polygon, the pentagon on top, pentagon on bottom. They're like mirror images of each other. This base would be flat compared to the other base. What are all the polygons we would need to generate that shape, that polyhedron? Okay, same thing here. So now we got a different one. If you notice, there's like a square on the bottom or a rectangle. I can't really tell, but you get to choose. And it comes to a point. So that would be named a pyramid. So again, it's a polyhedron, right? It's an enclosed figure. It's got all flat sides. But now we're getting more specific. This would become a pyramid. So that was object 2. All right, Last one. You would watch this Edpuzzle video. I'm not gonna watch this today because you guys are smart kids and stuff. And then it says respond to the discussion board by answering the following question: what is one thing that makes a prism and a pyramid different? And if you've been paying attention to the video and you walked through the lesson, you should be able to lickety-split identify that. Remember, prisms have something very specific about them. Every prism has these. And then every pyramid has these, but every pyramid also comes to a blank. So that's what I'm going to kind of leave you guys with. So please make sure you rewatch the video. Watch this. It tells you exactly what's going on. I wanted to kind of give you guys some hints of how and why we're doing stuff. And then I'm going to work through this at the beginning of class tomorrow. We're going to fly through these just like we did today. But very short lesson. Here's some important information for you. So if you're stuck, and again, some of you guys are printing these out and putting them in your notebooks. Other kids are copying the notes down, so you're more than welcome to do so. But here's a prism, again, connected by rectangles. And it's called a pentagonal prism because it has a pentagon base that matches the other pentagon base. This guy's a hexagonal pyramid because remember, every pyramid has triangles as the sides. And they all come to a point. They can have any base you would like, just as long as they have flat sides. All right? Faces, that's the sides. Net, two-dimensional version of a 3D. Polyhedron, enclosed figure with flat sides. Prism is some type of polyhedron that has two congruent bases, and they're connected by those rectangles. And last but not least, you have your pyramid. It could be rectangular, it could be hexagonal, it could be heptagonal. So there's all kinds of bases the thing has. The base is like the bottom I'm referring to. So rectangle is the base, hexagon is the base, heptagon is the base, but they all have triangular sides and they all come to a point. Triangular sides come to a point, triangular sides come to a point. So that's the definition of a pyramid. Okay? Don't get confused with a triangular prism and a pyramid because they're not the same thing. So your job now on this quiz would be to write your best definition or description of a polyhedron. If possible, use the terms you learned in the lesson. So you would go down here and you would fill that in. Okay, and remember, you can go back to the glossary and use those. Which of these 5 polyhedra are prisms? So remember, they have congruent bases connected by rectangles. Which of those would be prisms? Then, which of those would be pyramids? I'll give you a hint. There's 3 prisms, and there are 2 pyramids. So 3 prisms, 2 pyramids. Remember, this one might try to bite you because it looks kind of similar to one of the other shapes, but it's not. Okay? You would then submit your quiz. Obviously, I haven't answered it. We're going to talk about this in the beginning of class tomorrow. I'd move along, and we're good to go. Okay? There's some extra practice towards the end here, guys. So we would hit mission accomplished, but remember, this is a short lesson. I would move to my next piece. There's a synthesis video. There's lesson 13 video explanation. Pretty important to watch that, especially if you're struggling and you don't understand it. It's a 30-minute video, but it walks you through step by step by step. And you have your practice quiz. So you would then take your quiz. And this is basically questions that you're going to see on the test at the end of the unit. So trying to help you out best I can, guys. It's pretty repetitive. I mean, I know you already have the video, but I just figured this is your teacher telling it to you. I'm trying to hook you guys up, doing the best I can to make sure that you guys are successful. All right, see you guys when I see you.